All right, welcome to the Explainer. So, if you're a Java developer who works with databases, you definitely know the pain. The pain of queries that just break at runtime. Well, today we're diving into the architect's solution for this, the Hibernate Criteria Query API. Let's jump right in.
We have all been there, right? You write this complex query, you run your application, and bam, crash. A runtime error, all because of some tiny, infuriating typo like Fister name instead of first name that's buried deep inside a long string. It's so frustrating, and it's a risk you take every single time you build queries by hand. So, look at this. On the left, you've got the risky way. This fragile mess of strings just stuck together where one little typo can bring the whole thing crashing down. But then, on the right, that's the blueprint. This is about building your query methodically, step by step, using the safety and structure of Java itself to guarantee it's going to work. And that's really the big idea here. Stop improvising with these brittle, risky strings and start thinking like a query architect. Use a blueprint that makes sure your structure is solid before you even think about hitting run. Okay, so what does this blueprint actually look like in practice? Well, it's all about building queries that are strong, dynamic, and, most importantly, checked by your compiler before they ever get a chance to fail. The main tool for this job is the JPA Criteria API. And the magic word, the most important word here, is type-safe. What that means is your compiler basically becomes your own personal proofreader. It checks every part of your query as you write the code. It's the compiler that catches that first name typo for you, not your users in production. It saves you from that late-night debugging headache. Look, type safety is awesome. It's the headline feature, right? But the real game changer, the thing that will change how you work, is that these queries are programmatic. I mean, imagine a search screen with 10 different optional filters. With strings, that code becomes an absolute nightmare of if-else statements. But with the Criteria API, you just cleanly add conditions to your query object when you need them. It is built for this kind of dynamic complexity. All right, so if we're going to be architects, we gotta know our tools, right? The Criteria API basically gives us 4 key building blocks to construct pretty much any query you can think of. First up, you have the criteria builder. Think of this as your master tool factory. Anytime you need to construct a piece of your query, a condition, a function, an ordering, anything, you go to the builder and ask for it. Now, the first thing you ask that factory to do is to give you a criteria query object. And this right here, this is your actual blueprint. It starts out totally empty, and we're about to add all the different pieces to it. Okay, so you've got the blueprint. The very first thing you need is a foundation. We call this the root. All it does is tell the query which table you're starting from, like from student, and it gives you a safe way to get to its column. And finally, you add the rules. These are kind of like the walls and windows of our building. We call them predicates. Each one is a single condition for your where clause, like last name equals Doe. You create them with the builder, and you add them to your query. So let's recap. You've got a builder, the blueprint, a foundation, and the rules. That's it. That's the whole toolkit. All right, enough theory. Let's see how this actually works. We're going to take those building blocks and put them together to craft a basic select query step by step. So let's just walk through the code. Step 1, we get our criteria builder and use it to create our criteria query blueprint for the student entity. Next up, we set the foundation for the query by defining the root. Now for the rule, we use our builder to create a predicate that checks if the student's last name is Doe, and then we add it to the where clause. Finally, we hand this finished blueprint to the session, which runs the query and gives us back our list of students. See? It's all clean, it's totally clear, and best of all, it's 100% type safe. No typos allowed. Okay, so retrieving data is one thing, but what about when you need to change a ton of it at once? For that, we need to bring in the heavy machinery, because the Criteria API is for way more than just select statements. And this right here, this is the key to understanding the efficiency. Think about it. Normally, if you want to update, say, 1,000 records, you would have to load all 1,000 of them into your app's memory, change them one by one, and then save them back. It's incredibly slow and eats up memory.
But bulk operations let you tell the database directly, hey, just update all the records that match these rules, without ever touching your application's memory. It's a huge deal.
And the two main tools for this job are criteria update and criteria delete. I mean, the names pretty much say it all, right? One is for doing bulk update statements, and the other is for bulk delete statements. And both of them happen right inside the database where the data lives. And you know what? The process for building a bulk update is going to look super familiar. We start by creating a criteria update object and defining its root. But instead of selecting data, we use the set method to say what we want to change. Then, just like before, we add our where clause using a predicate. And the final step is to call execute update, which fires off one single efficient command to the database and tells us how many rows it changed. And that number you get back, that updated rows integer, that's your proof of just how efficient this is. If that number comes back as, say, 5,000, it means you just updated 5,000 records without using even a byte of memory to hold a single one of them in your application. That is a massive performance gain, and you did it with just a few lines of clean code.
Okay, so with all this power, you might be wondering, when should I actually reach for this? Because let's be honest, for a super simple static query, this can be a little bit of overkill. So here's the bottom line. You should absolutely reach for this brew part when you're building those complex, dynamic queries with a bunch of optional filters, when you need to guarantee type safety, when your code is just becoming a mess of string building logic. And honestly, for any bulk update or delete, it should be your default choice, period. The performance benefit is just too good to pass up. And that really brings us back to the main question here. The next time you're faced with building a complex database query, the choice is yours. Are you going to keep improvising with those risky, fragile strings? Or are you going to use the architect's blueprint to build something solid, safe, and professional? Thanks for joining me on The Explainer.